Welcome America, India, and Selena Gomez to live studio recording in 202 of the notes for geometry for properties of trapezoids and identifying special quadrilaterals. Okay, I'm gonna try to make this as efficient as possible. So I already wrote up some stuff here, so I won't have to rewrite it. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. And the bases of the trapezoid, so here's an example of a trapezoid. The bases are the parallel sides. Those are the bases, okay? The legs are the non-parallel sides. And the base angles, we have two sets, right? Here's, the base angles are on either side of the parallel sides. So we have one pair and we have another pair there. An isosceles trapezoid is a specific type of trapezoid where the legs are congruent. So I put a little mark there to show you the legs are congruent. So if a trapezoid is isosceles, okay, if we're told it's isosceles, so right here, legs, same length, then each of the base angles is congruent. So you know, if it's isosceles, you know these base angles are going to be congruent, those base angles are going to be congruent. This is an example of a trapezoid. We've got one set of parallel sides where the legs are not congruent and the base angles are not congruent. So we're gonna move on. And right here. All right, so 8:15. If a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. Okay, and you can see, do you remember from the base angle theorem of a triangle? Okay, if these base angles are the same, the sides opposite those angles are congruent. It's the same with the trapezoid. An isosceles trapezoid is an isosceles triangle with its head cut off, right? Just cut it off. There we go. So if the measure, where am I? Yeah. If angle A is congruent to angle D, okay, or B is congruent to C, then the trapezoid ABCD is isosceles. And notice we're naming the trapezoid at its vertices, A, B, C, D. And they chose to start with A and just go around this way. If they wanted to, they could have named it D, A, B, C, okay? Theorem 8.16, a trapezoid is isosceles if and only if its diagonals are congruent, okay? So if you're told you've got a figure where you've got one set of parallel sides and the diagonals are the same length, then you know that the trapezoid is going to be isosceles. So trapezoid ABCD is isosceles if and only if AC is congruent to BD. All right, moving on. Example number 2. A shelf fitting into a cupboard in the corner of a kitchen is an isosceles trapezoid. If you guys ever had a table that's in a corner, kind of looks like this. Find the measures of angle N, L, and M. So I'm going to write that. Measure of angle L, measure of angle N is first. Then L, then the measure of angle M. Okay. So the measure of angle N, we are told it's isosceles. So we know the base angles are going to be congruent. So if the measure of angle K is 50 degrees, the measure of angle N also has to be 50 degrees. Now, this is the hardest part right here. Back from Unit 3, when we have parallel lines and a transversal, the consecutive interior angles are supplementary, which means the measure of angle L is going to be the supplement of 50 degrees. That's going to make it 130 degrees. And since it's isosceles, angle L and angle M, their base angles, they should be congruent. So the measure of angle M should also be 130 degrees. Now, try this problem, press pause, see if you can try it. I'm going to give you the answer. Find the measures of angle C, measure of angle A, and the measure of angle D. Okay, so measure of angle C has to be 135, because those are base angles, they're congruent. We need A and D to be the supplements of B and C, so that's going to be 45, because 45 plus 135, those two angles are going to be supplements of each other. 135 plus 45, 180. Now we're going to identify special quadrilaterals. And there we go. So quadrilateral ABCD has both pairs of opposite sides congruent. Both pairs of opposite sides. These two sides are opposite each other and they are congruent. And these two sides are opposite each other and congruent. What type of quadrilaterals meet this condition? Well, we've got here a parallelogram. Okay, and they really should have told us these are all 90 degrees. So they're trying to show us that that is a rectangle. Yes? And we don't know these angles, but we know all the sides are congruent, so this is a rhombus. And this one should have all right angles. That should be a square. Checkpoint. Quadrilateral JKLM has both pairs of opposite angles congruent. What type of quadrilateral meets this condition? Well, let's take a look. Opposite angles. This pair of opposite angles are congruent, and so is this pair. Well, that's going to be a parallelogram. And then we're going to have to list the types of quadrilaterals that meet that condition. So we're going to have to list all the parallelograms. So we've got a rectangle, a rhombus, and a square. Now in the last couple, they're asking for the most specific name. All right, so we take a look at the information and ask, example 2, what is the most specific name for this quadrilateral? They've told us it's a quadrilateral, it has 4 sides, and all the sides are congruent. But they've told us nothing about the angles. So it looks like a square, but we can't say it's a square because we don't know that all those angles are congruent. So we're going to have to say it's a rhombus. And the last one we have, is there enough information given in the diagram to show the quadrilateral FGHJ is an isosceles trapezoid? All right, well, let's take a look. We do have base angles that are congruent. We know the sum of all those interior angles in any quadrilateral has to add up to 360. So first of all, pause and just go up one sheet on the other side and read theorem 8.15 and then come back to this. All right, you read it. All right, so if we have base angles that are congruent, we know that these sides opposite them are going to also be congruent, right? So we know it's going to be an isosceles triangle. So how can we show that FGHJ is a trapezoid, has one set of parallel sides? Well, we have consecutive angles that are supplementary, right? So if I were to draw these two lines and I've got my transversal, I can tell that these two lines are going to be parallel. So now we've got, for sure, we've got a trapezoid. So I'm just going to write here as my work, 78 plus 102 equals 180. Here we go. So FG is going to be parallel to FH. FG, FG, what letter is that? Where's the name of the quadrilateral? HJ. I'm just gonna say JH. Okay. And then is the trapezoid isosceles? Okay, well, we just talked about the base angles being congruent. So by theorem 8.15, we know that FJ is congruent to GH, FJ, GH. Those are congruent. We just talked about that. So it's isosceles.